welcome to the CarboHydrate Chronicles, a podcast about glycoscience and glycoscientists. In this show, via a series of interviews, we'll explore the world of carbohydrate science and innovation from a personal point of view. Your host today is Tamas Shohaid, a member of CarboHydrate's scientific team. Glycoscience is the study of carbohydrates, so sugars, and their roles in biology. Today, we are focusing on lectins mainly. Lectins are carbohydrate-binding proteins that are highly specific for certain sugar groups. Lectins have a role in recognition at the cellular and molecular level, and they play numerous roles in biological recognition phenomena involving cells, carbohydrates, and proteins. Lectins also mediate attachment and binding of bacteria and viruses, fungi to their intended targets. Our guest today is Anne Imberty, senior researcher at CNRS Grenoble, whose present research projects are centered on lectins from opportunistic bacteria that are involved in the first steps of infection. Structural characterization of these lectins and of their interaction with human glycoconjugates is opening the route for the design of glycocompounds with antibacterial actives. So today I have the great honor to welcome Anne Imberty, the godmother of lectins. Welcome, Anne, and thank you for accepting the invitation.
Thank you, Tamas, for this nice introduction, and also thank you to CarboHydrate for this idea of podcast. It's rather unusual, but I think it's a nice opportunity for promoting glycoscience in general.
Yes, we also hope that it can bring this niche and fairly new research field a bit closer to the public and make some publicity because, we also believe that it's very important to deal with this upcoming research area and a very complicated research area. Anne Imberty has decades of experience in glycobiology. She worked at different institutions of CNRS in Grenoble, in Nantes, in Paris, also at the University of Toronto. She is the author of over 300 papers, leads diverse fields of research in glycoscience, and actively participates in both education and spreading the knowledge in this field. And you have done research all throughout France, several big cities. Where are you originally from?
Well, I'm originally from a small city not too far from Grenoble in France, in the mountain, and there is no university there, but my parents were teachers. In fact, they were sport teachers, but my father was very motivated by all sciences, so he brought us to the mountain, and we learned to observe plants and nature, but also archaeology or medieval history. So I think he taught my sister and me to scientific curiosity. This is what was important, and also love of nature. And then at school, and especially maybe at gymnasium, I had some excellent teachers, mostly in biology. So I decided to go to natural science. But it's difficult to choose because I love nature and plant, but also geology and volcanoes. So first I started to be a biology teacher, just teaching biology. And it's only when I visited laboratory that I discovered research and decided, no, maybe research is even more interesting than teaching. Yeah.
I see. So your childhood memories in mountains and family hikings, is that the source of affection to wandering and the love for the mountains?
Yeah, also the love for for hiking. I always keep interest in hiking. Yes, and let's say the beauty of nature in general. Yeah.
So if I understand correctly, you haven't planned to be a researcher from the very beginning. It just you had this affection towards natural sciences, all kinds of natural sciences, and then life guided you in this direction. Is that how it was?
Yeah, this is what happened with, because in this school to become biology teacher, you have the opportunity for an extra year where you can work in a laboratory. I went to a laboratory working in plant science, and that was at the moment lignification, I think something to do with peroxidases and lignin. And then I discovered plant cell wall and their beauty and complexity. Then I decided to do research. And from that, I continue with a PhD on starch granule, and this led me more to chemistry and physics, because it was with X-ray diffraction. And then I was definitely in love with carbohydrate at this moment. So that was why plant from cell wall to starch brought me to carbohydrate. Yeah.
So, and was it love for the first sight when you started working with carbohydrates? Did you enjoy them from the very beginning, all the complexity and the undiscovered marvels?
Oh yes, because then I went for a stay in Toronto, wanting to learn more about human glycan, because at the moment it was on glycoprotein, and I learned a little bit of NMR with Jeremy Carver there. It was a lot of shimming time spent to the NMR, and then discovering the complexity then of human glycan. This was another degree of interest, because the cell wall or the starch granules, the complexity was more in the architecture, and then coming to the human cell, it's more in the chemistry and biology. So with all these aspects, it was definitely a passion for carbohydrate. Yeah.
How about the other natural sciences? Do you still have this fascination towards them? What you mentioned, the biology, the geology. So have you kept those interests as a hobby?
Yeah, I would say I love bird watching or finding plants, and I think I always kept this interest in geology. We went to Iceland when the volcano exploded, because I wanted to see a real volcano. We went to Etna and other volcano in Mediterranean. So yeah, in general, natural. In science, I have a general interest, yes.
If we look closer on your work with carbohydrates, what is the aspect that caught you within glycoscience? So what is the part of this research that could bind you for 40 years in?
Well, I think you cannot be bored with carbohydrate, because there is first the different scales. You can work at the atomic level, looking at hydrogen bonds, and then you can change scale and work at glycan, and then in architecture, very complex architecture in cell wall. I mean, like bacterial cell walls, they can be so huge and complicated. So these different scales, they are very interesting. And then it's also interestingly interdisciplinary. You really have to have some knowledge and some interest in biology and chemistry, in physics also. I have been educated in biology, so learning chemistry was not that easy. And also because it's interdisciplinary, you have to work in a collaborative way with colleagues. And this is very important for me, having collaborators and working together. And this brings also friendship and interaction. So this is why carbohydrates are nice also. And you can spend a whole life in carbohydrate. Yeah.
Yes, I completely agree about this part. So for someone who is so fascinated in different aspects of natural sciences, that's indeed a very, very good pick, because interdisciplinary nature, especially if you're thinking about pharmaceutical applications, you need to focus on very different angles when you look at a problem. Currently, you focus more or less on lectins, but you have a very comprehensive overview of glycobiology or glycoscience. Which are the areas of glycoscience that you were most fond of during your career?
Well, I think the role of lectins in infection, that was really a turnout in my career. That was also one of the most exciting time, because when we could identify the structural base for how Pseudomonas aeruginosa bind to human tissue, this was very exciting. These bacteria, they are harmful for immunodepressed patients, kids with cystic fibrosis. And so because we discover which sugar they bind, and also the atomic structure, and we work with chemists to do anti-infectious compound. And I worked also with the Cystic Fibrosis Foundation to be involved in the project call and to discuss with a family of patients. And all together, finding how lectins can attach to human tissue. That was very opening different way of thinking, and it was particularly interesting. Yeah.
That's a very important project. Where is this research now on the stage of development?
Yeah, we still work on it because we are looking also at lectins from other opportunistic pathogens, bacteria or fungi. And as for the Pseudomonas one, we are still collaborating with carbohydrate chemists around the world because we help them characterizing the anti-infectious compounds they are developing, and we are doing the assay. We have been associated with several patents for anti-infectious glycomimetics. We tried to convince some big company to continue on this subject, but it's difficult. I suppose we should have started our own company at some time because at the moment it's difficult.
It's interesting that you mentioned that maybe you should have started your company or a company around this research. If I'm not mistaken, you have worked all throughout your career in academic institutions. Was this always the plan, or it just happened by chance, or have you never, I don't know, wanted to work in the private sector?
Well, I think when I was a young researcher in France, it was really separated, private and the academia career. We were not encouraged to go to private company, and it was even considered not as noble as academia. What I see since the last 10 years, it really changed. And now I think that in many companies, especially in the small companies, there is a dynamism, really a strong activity, which is very interesting. And yeah, maybe it would have been different with the atmosphere now. Maybe I would have gone to a private company at least for a part of my career, but well, it did not happen. Yeah.
On the other hand, you did some very, very important moves to make glycoscience bigger and more popular. So you participated in the creation of GlycoOps, which is, we think, maybe the biggest glycoscience community, local community currently in Europe. Could you tell us more about GlycoOps and what is this?
Well, this was an effort to bring together again interdisciplinarity. We realized that in Grenoble, we had colleagues working on pulp and paper, on biomaterial, and others working on pharmaceutical and or biology of bacteria or human biology, and that everyone was working on a carbohydrate in a way or the other in this community. So bringing people together from material science, chemistry and biology was very interesting, and it worked very well. And we really had some exchange. And now we are also expanding to economy science, so looking at the economy of carbohydrate, and we had some project on this, and we learn a lot. And we continue also towards architecture and housing, how to use biopolymer in, for example, in painting for walls or in making novel architecture. So it's funded by the university in Grenoble. We have a lot of animation. We have summer school. The students are together. So it's a very interesting project. Yeah.
And when you're not in the lab, do you mention to get enough time out of the lab to devote to your hobbies?
Yes, well, yes, mostly now it's better that I'm a senior researcher. So I would say for women, when you have a family with kids, you have kids on the lab, and it's difficult to have hobbies outside. But when kids are grown up, then you can develop some other hobbies. So I still enjoy family life and grandchildren, and I love to read mystery books and stuff like that. But I say I spend a lot of energy in hiking in the mountain or organizing a trek for the summer and planning it and all this stuff that are, let's take a little bit of time, but are really, let's say, rewarding at the end. You can really organize very nice hiking and enjoy it after, yeah.
Do you just go for the local mountains or you also travel abroad, I don't know, to hike new peaks in certain places?
Oh, yes, we go to everywhere here in the Alps. Italy has nice places, and this year we plan to go to the Pyrenees on the Spanish side of Pyrenees. And in all cases, we enjoy going to refuge and have nice cuisine. So Italy is very good. I'm sure that in Spain we will also have nice hospitality in Spain.
Do you have a favorite spot for hiking in the world globally that you, I don't know, have a very special connection to?
While still my mother is still living in this small town near Italy in the Alps, and I'm sure that it is the most wonderful place for hiking in the mountains. So this is Briançon. It's near col of Mont Genèvre at the Italian border, and yeah, this French-Italian Alps. So really a nice spot.
I've never been there, but I should check it out one day. If you don't mind, let's talk a bit about your current research and lectins. Could you tell me some exciting discoveries or research fields that you are currently particularly excited about, and you think that they're forming the future of glycoscience? Not necessarily your research, in general. What do you think? What are the main areas that we should keep a close eye on?
Well, at the present time, we are trying to get a broader view of lectin, and this is a collaboration with Frédéric Lizasek in Geneva. So we are developing database and mining tool to investigate genome to find the new lectin and to analyze all the possible arrangement that lectins, when they are associated with other protein or enzyme. This is a word to be explored, and it's much in connection with all the work that is done now on microbiome. I'm sure that in microbiome, there are so much new carbohydrate, polysaccharide, and lectins, and new enzyme also to be discovered, that it's really exciting. And it's important also, we know, for human health.
I completely agree with that. In one of your presentations, you grouped the potential applications of lectins into three main categories. One was their uses in the field of diagnostics and biomarkers. You mentioned potential uses as targetors or vectors for different therapeutics, and you also discussed their potential use as therapeutic agents. Which of these fields do you think has the biggest potential to grow out of the academia into human applications?
Well, the biosensor direction is already well developed, and there are many companies starting to lectin array or other sensor based on lectins. This can be developed if we can control the production of lectin better. So we need to have lectins that have specificity well controlled, and while we can discuss, I think this is one of the most challenging domain at the moment, how to design carbohydrate binding site with a particular specificity. At the moment, we are doing a lot of engineering because we want to use lectin as tools. So we can engineer the architecture of lectin. We can bind several lectin together. We can attach them to other domain. But if we want to change the specificity from galactose to N-acetyl galactosamine, then it is very tricky because nothing looks like a sugar more than another sugar. They are quite similar in stereochemistry, in shape, and this is difficult to control. So maybe I would say with the deep learning approach, artificial intelligence, if we can take together all what we know about the structure and specificity, maybe we can manage this in the next year. I'm sure there will be some progress on this aspect. So this is for the biosensor. There are some progress to be made, but biosensor exists. As for therapeutics, it's coming slowly, mostly maybe on cellular therapy. If you can target lectin and do this CAR cell therapy or directing antibody or other, there will be some development, but at the moment you cannot really inject lectin into someone blood. There are carbohydrate binding molecules that create problem with blood group cell and others. So it's mostly for cellular therapy that they can be useful outside of cell.
Most of the applications, as far as I understand, are related to cancer. Could you explain the listeners why is that? Why is cancer in this special position for lectins?
Yes, well, in cancer, there is an alteration of glycosylation on cancer cell. This is very well established now. What did not happen maybe as expected, it's not one glycan that is a cancer signature. So it depends on the cancer, it depends on the type of cell, and it's very related to personalized medicine. We have really to analyze what's going on. But in some cancers, there is a clear change of glycosylation that can be marked by a lectin. And it can be very useful in this case to have a direct label. For example, when a surgeon take out a solid tumor from the body of someone, if he can quickly have a marker that indicate to him tumor is completely removed, so to see the margin of tumor, for example, directly without waiting for a few days is very useful. So having very efficient label for tumor is a progress, yes, and there could be some development in this area. Of course, there is also the question of tumor marker in circulating in plasma. This is what everyone is looking for, and there are some glycan that are used now for prostate cancer, and they are very useful, and there could be some more development in this area also for sure.
Okay, so the altered glycosylation is a straightforward driver towards cancer research. Are there therapeutic uses or research areas where such kind of unique glycosylation happens? There could be other target areas for glycoscience apart from cancer.
Apart from cancer, well, there are some related to inflammation where you also have a change of glycosylation, but I would say that mostly the other domain is infection, for sure, that either for viral infection or bacterial infection, and now for fungal infections that are becoming more of a problem. There is protein carbohydrate interaction. Generally, there is lectin carbohydrate interaction, either lectin from the pathogen binding to our sugar or our lectin binding to sugar on the pathogen. So in all cases, if you can either stimulate it or block it, it will be a progress. And then it's also related to immunology, and there are more and more knowledge of glycoimmunology, how the our lectin interacting with sugar on the pathogen stimulate the immunology cascade, and in some case overstimulate it. So in all these areas, there is many things to discover. So I would say infection and immunology are the two other axes for glycoscience on top of cancer. Yeah.
And you're very active both in research activities and education. Is it, I don't know, 50-50 in your time, or it's shifted the balance towards one of them?
Well, I'm not that active in education because in France, when you are in academia, you enter either as a university fellow, so associate professor on the career, or as a government researcher in CNRS, which I am, and then you are not too much devoted to teaching. So you can apply to do some teaching, and I did some at some part of my career, but I spent quite a lot of time in, let's say, management of research. So either I was head of the institute in Grenoble for 6 years, and I was also working at CNRS in Paris as in charge of interdisciplinarity for the chemistry department. So yeah, I was more involved in management, but sometimes at really education.
One last question, and at the time asking all the guests. So if you could have a dinner with any historical figure or celebrity or dead or alive, who would it be and why?
To have dinner with someone who has many stories to tell. So I think I like the great explorer, the one who discovered new country or the pole. So maybe Amundsen, who discovered the South Pole, because if you can imagine how it will be to be for months with a team and discover a new country and new landscape every day. So yeah, I think I would love to have dinner with Amundsen and ask him to tell me how was it there. Yeah.
Yeah, that's a very nice answer. And you could probably tell him about your hiking stories and hiking
Oh,
experiences.
yeah,
So
nothing to compare, no?
So I hope you enjoyed the next episode of Carbohydrate Chronicles today, delivered to you by CarboHydrate. We talked with Anne Imberty, senior researcher at CNRS Grenoble, expert in lectins, and or we could say that expert in glycoscience in general. Capturing Anne's views, we cannot be bored with carbohydrates. Every new day brings a new challenge. They are so complex with so many interactions, so many skills to study, and so many applications that we can find a new fascination every day. And this research is certainly interdisciplinary, which leads to a lot of collaboration and friendship. And I really liked your quote or saying that nothing looks more like a sugar than another sugar. And we see and we know that how similar they can be. So creating something that's specific is indeed a very big challenge. So thank you for being with us today. And this was a fascinating discussion, and maybe we can continue uphill during hiking in the French Alps one day. That I would love, certainly.
Thank you, Demet. That was a pleasure.
Thank you all for listening to this interview. Next week, in our upcoming episode of Carbohydrate Chronicles, we'll talk with Francesco Trotta, professor at University of Torino and vice president of the European Cyclodextrin Society, whom you may also know as the inventor of nanosponges. And what are nanosponges? Well, that you can learn next week. Your host was Tomas Shaheda from CarboHydrate. I hope you will join me in our next episode too. See you in 1 week. Goodbye.